Good morning. First of all, I'd like to thank Dr. Benfield for inviting me to speak this morning, and especially thank him for inviting Dr. Osmond. What a wealth of knowledge and expertise. We can learn a lot from that in the state of Ohio, and I did notice that she was quite complimentary of what's going on in Ohio. So as we look towards these discovery theme hires, it might be an area to look towards North Carolina State. Think about that. So over the last few months, I've had a lot of questions about Field to Faucet. What is Field to Faucet? What's going on with Field to Faucet? So I'd like to try to answer some of those questions today. I've also had a lot of questions about the Global Water Initiative. What is the Global Water Initiative and what's going on in the Global Water Initiative? So today I'd like to start out briefly defining the Global Water Initiative, talking a little bit about that, and I'm going to spend the majority of time focused on Field to Faucet, as the title of my talk would lead you to believe. And I'm going to start by defining three challenges related to global water. First of those is water security and water supply. Bruce mentioned this in his remarks. This is something that's an endemic problem around the world. It's been identified by such groups as the World Economic Forum as the highest global risk in 2015. Coastal resiliency. As our sea levels continue to rise, our coastal populations continue to swell, coastal storms continue to get more frequent, more intense, we're going to be challenged to design cities, design urban areas around coastal areas to withstand these threats. This is a picture from 2005 in New Orleans. I could have picked a picture from Superstorm Sandy, many more recent events in Southeast Asia as well. And the last of the three is are harmful algal blooms or algal blooms. This is a picture from China. We all know in Ohio, this is a big threat to us in Ohio, Lake Erie, across the state of Ohio. It's actually taking place worldwide, and I'll point that out later. And these three global issues represent the scope of the Global Water Initiative. And so as we try to become the land-grant university of the future, it's very important for us to look not only at issues that are impacting us in the state of Ohio, harmful algal blooms, but look at what's happening globally. So what I'd like to do right now is talk just a little bit about these three different areas. Wells to Wellness is the Global Water Initiative's response to rural water supply. Then I'm going to move to coastal resiliency. And lastly, stick with Field to Faucet and talk about that for the majority of my time today. Yeah. There we go, Wells to Wellness. So Wells to Wellness, we're initially focused on Tanzania. Our college has had a rich history in Tanzania. Mark Erbaugh in the College of in the international programs has a large USAID project going on in Tanzania. So this was a logical place for us to begin with global water. Within Tanzania, there's over 5,000 non-functional drinking wells that were installed by past NGOs, past efforts to supply drinking water in the country of Tanzania. Initial research, we've identified about 135 of these wells to restore. These wells are the ones kind of the lowest hanging fruit with the best water quality, the highest water tables we can get off the ground quickly, get back up to service. After we get these 135 working, we're going to expand to other wells and hopefully bleed also into power and economic development in the future. To the left-hand side, or to your right-hand side up here, I guess, is a picture of an event that happened just a couple days ago here on campus. Bruce is sitting here with Carol Whitaker, the Dean of Research. In between the two of those is Professor Malacha from the University of Dodoma from Tanzania. And they signed a memorandum of understanding that pledged the support of the University of Dodoma to support this Wells to Wellness program. So this is really off and running. What's also important in this picture, you see two leaders from important NGOs that have people on the ground in Tanzania. So this Wells to Wellness program is off and running. Moving to coastal resiliency, this is the third pillar of Global Water Initiative. To be honest, this is the newest pillar that we've started to work on. Withstanding that, GWI has gained external recognition, so in just a few weeks I'll be headed to the Netherlands to represent OSU on the UNESCO Coastal Resilience Collaborative. Other partners that will be included are MIT, Stanford, and LSU, and they will be working to identify strategies to make cities more coastal resilient in the future. We've also been invited to partake in the UN RISE team, which is identifying sea level rise strategies in the future. So while we're just getting started here, we do have some important recognition internationally. So with that being said, I want to move on to Field to Faucet and move on to the talk that you all were planning to hear today. I hope that you do have a brief understanding now of global water and where Field to Faucet fits in with that. So with Field to Faucet today, I'd like to talk first of all about some impacts of phosphorus in the state of Ohio and globally. Then I'd like to move into the steps forward that I'm talking about here in the title. So what projects are going on related to Field to Faucet, what's happening, and I'd like to end with some future steps related to Field to Faucet. So I think this editorial cartoon from the Dispatch that came out just after the Toledo event really says it all as far as the biggest impact that we're all familiar with harmful algal blooms. This is really what took harmful algal blooms from an issue that affected fishermen or affected beachgoers to something that affected everybody, and everybody knew about it. As Bruce said, Bruce's analogy to the family that didn't have water to run for their children or didn't have water to run a restaurant. Everybody knew about this. It made national headlines. For me personally, it made it much easier to explain my research. Before this happened, I would tell my friends or my family, I'm working on water issues related to Lake Erie, blah, blah, blah. After this happened, all I had to say was, I'm working on harmful algal blooms in Lake Erie. And they said, oh, okay, now I know what you're talking about. So anyway, it made things easier in that regard for me. But this really brought things to the forefront, resulted in legislation. It's actually resulted in the Field to Faucet program as well. What I'd like to talk about now are some of the less well-known impacts that you might not have heard of. There have been other drinking water bans. Toledo is not alone in drinking water bans in Lake Erie. So Toledo, it happened in 2004. Monroe, Michigan also suffered a drinking water ban in 2014, And Pele Island, a Canadian island, which is just north of Stone Lab or Put-in Bay, maybe some of you vacation there, it also suffered a water ban in 2014. A year before this, in 2013, Carroll Township in Ohio suffered a drinking water ban. So this is something that's happening more often, and I think we really need to be prepared for this. This is a big threat to our public health, economic development in the state. And as you see, as we move forward in Field to Faucet, you'll see this is one of the areas that we've really directed investment at to try to maintain drinking water quality. Impacts on the aquatic ecosystem. We know these are happening. We don't know much about them. At the top of this slide, you see cyanobacteria. These are the bacteria that have microcystin, that have the toxin in them. At the bottom of this slide, you see fish. These are the game fish people go to Lake Erie to catch, such as walleye. How do we know that these impacts are happening? For one, we've been monitoring the fish, walleye in Lake Erie, and we have found trace levels of microcystin in walleye. Before I go any further, I want to emphasize that these are trace levels. We have not found anything above what is considered hazardous for public consumption, so I'm still consuming the fish, and everybody should feel safe to consume the fish. But we do know this is happening. We also know the food web's changing. The prey quality is changing. So as more cyanobacteria are in the lake, cyanobacteria are inedible to the fish. The good phytoplankton that are in the lake are decreasing, so there's less food for the walleye to eat, or actually the fish that the walleye eat to eat. So it's impacting the food chain. So Dr. Stu Ludson's leading a lot of this work in Aquatic Ecology Lab, and we're just learning some of these things, but this is a very important impact as well. This is not just something that's happening in Lake Erie, it's happening across the state of Ohio. Annually, about 22 water bodies across Ohio and 22 counties are impacted with recreational water advisory postings. No swimming, no fishing, no boating. Grand Lake St. Mary's is probably the poster child for this as far as inland lakes in Ohio. So across the state of Ohio, this is having impacts. This isn't just something that's happening in the state of Ohio, though. This is something that's happening across the globe. The Water Resources Institute identified over 700 areas, coastal areas, that are degraded by eutrophication or hypoxia. The commonality here is that there's too many nutrients coming from the upstream area and impacting the downstream area. Eutrophication is too many nutrients. Hypoxia is the result of too many nutrients and low oxygen levels in the downstream areas. As Dr. Osmond, and we've heard before from Bruce, the area besides Lake Erie that's probably most relevant to us here at Ohio is the Gulf of Mexico, where about 2/3 of Ohio drains to. Here the issue is nitrogen, as we've heard before. For us in Ohio, it's phosphorus, as we've also heard before. I'd like to take just a couple slides to talk about why we're looking at phosphorus. If you just look at the bottom graph here, and this comes from a lot of the data from Heidelberg and Pete Richards, as Dr. Osmond mentioned. Just looking at the bottom graph here, you see the DRP loads, that's dissolved reactive phosphorus. So we know enough that we're not only just interested in phosphorus, but we're interested in dissolved reactive phosphorus. And if you can read that, you can see that over the last 20 years, the dissolved reactive phosphorus that's coming out of the Maumee River has almost doubled. So that's a troubling trend. There have been a lot of studies similar to this one by Doug Kane, which show strong relationships between the amount of soluble reactive phosphorus, which is a different way of saying dissolved reactive phosphorus. On the bottom of this graph is dissolved reactive phosphorus. On the vertical axis is the cyanobacteria, or the amount of harmful algae in the lake. Very strong relationship. So we know that the increase or the amount of dissolved reactive phosphorus going into Lake Erie is stimulating, is leading to these harmful algal blooms. Very clear. We're also focused on agricultural runoff, as we heard Dr. Osmond say. Why are we focused on agricultural runoff? That's the dominant land use within these areas. So if you look at the middle here, you see the tributaries to Lake Erie, to the Lake Erie's western basin. And over 70% of that area draining into western Lake Erie has row crops on it. Okay, so we're focused on that. So what I'd like to do now is just take a little break from the slides, summarize before I move into field to faucet. So I hope that you all have a little bit of appreciation for what the Global Water Initiative is. I'm happy to talk more about that later on. With regards to harmful algal blooms, these are having important impacts in Ohio. Okay? Drinking water bans, impacting the aquatic ecosystem. What was the last one I mentioned? Nobody's listening. Beach closures, that's right. And I can't remember it either right now, but beach closures. So there's important impacts happening here. And we also are pretty clear about what's causing these, what the problem is. It's phosphorus, it's dissolved phosphorus, it's coming off of mostly agricultural lands. Okay? And looking at this problem, and especially what happened in Toledo, Field to Faucet was launched, and Field to Faucet is directed at these problems. So the approach for Field to Faucet, we're focused on an end-to-end system. The name says it all, Field to Faucet. So we're looking at what's happening on the field, trying to reduce the amount of phosphorus nutrients coming off the field. Looking at the faucet, as I said before, it's vitally important to maintain public health, to maintain that drinking water supply. We know it's going to take us more than a year, more than 3 years, more than a decade to really have a huge impact on the harmful algal blooms in Lake Erie. During that time, it's vitally important to maintain the public health and maintain the drinking water supply. So that's where the faucet comes in. Sustainable food and safe water. We want to accelerate applications. There's a lot of great research happening within the basin right now, has been for many decades. It's important to integrate that research, get applications on the field, use the extension network that we have a great one of here at Ohio State, and collaborate with other agencies and universities to identify and address knowledge gaps. That being said, Field to Faucet is a new initiative, but what we really need to do is build off of past and ongoing expertise here at OSU. We can't forget our foundation that we have here. There's a lot of great knowledge here: conservation tillage, soil P-index, watershed modeling. Water quality trading is something we do really great here. Sea Grant and the Aquatic Ecology Lab here at Ohio State have been working in Lake Erie and the Great Lakes for decades, if not longer, and have a wealth of knowledge there. We've developed a lot of the best management practices here at Ohio State, so we have a huge foundation to leap off of as we go into Field to Faucet. A brief timeline, a very brief timeline of Field to Faucet. It was launched at Farm Science Review on the 16th of September by our dean, Bruce McPherson. At this time, he also pledged $1 million in support to get projects started right away. Later on in the fall, OSU and University of Toledo were selected to manage a $2 million investment from the Ohio Board of Regents, and these projects will be starting soon. So what I'd like to do right now is talk a little bit about these projects, since they're one of the main focuses right now of what's happening in Field to Faucet. Before I do that, I want to acknowledge Sea Grant. They've been a huge supporter, huge collaborator as we rolled out these projects, identified investigators, and are now planning to manage these projects. So I want to acknowledge Jeff Reuter and Chris Winslow have done some really great work here, and the other support staff at Sea Grant. So initial investment of $1 million for Field to Faucet. We identified these 5 projects on the bottom here. Before I talk briefly about these projects, I'm going to talk about the process of identifying these projects. We got a group of faculty from across the university, Ag College and other side of the river as well. We also included some important stakeholders, NRCS, USDA as well, and tried to identify important needs, but also important needs that fell into the expertise of the people here at Ohio State and in the state of Ohio, so that we could have projects that would produce some very, very important but very timely results. With that in mind, we started with a project looking at field management applications, better known as apps. I think this is a big word we're talking a lot about now. A lot of farmers already use handheld devices to record data, record field practices. So John Fulton's formalizing this by developing some apps so that farmers can enter their information right into an application, store it, use it next year, make this a formal type of deal here. In the future, he hopes to move on into BMP apps and things like that. With that, a closely related project is the Data Co-op being led by Scott Shear here in our college. The Data Co-op's an idea of taking some of this information that John's going to collect on these field management applications, linking that with water quality and storing that in the cloud. Then it'll be available to agricultural producers to see what are the best ways to increase productivity. It'll also be available to watershed modelers to look at, to have a better knowledge of what types of practices are happening on fields. So hopefully we can link those practices to water quality changes, just as Dr. Osmond talked about. Manure recycling, come on, yep. Manure recycling, this is something doesn't have so much applicability to Northwest Ohio. In Northwest Ohio, there's just about 10% of farmers that actually land apply manure. It's much more applicable to what's happening in Grand Lake St. Mary's, where we have a lot more livestock. This is a project that Dr. Yibo Lee is leading, and what he's trying to do is extract the nutrients from the manure so that the manure could be land applied without further contributing to nitrogen and phosphorus runoff from this manure application. The last 2 projects, bloom detection, which is being led by Ji-Young Lee in the College of Public Health, and a microsystem detector being led by Dr. Wu Lu in the Department of Electrical Engineering here at Ohio State. These are focused on drinking water. As I mentioned, this is a really important focus to maintain drinking water supplies in the future. One of the problems with producing safe drinking water right now is that when a sample is collected, it takes 12 or 24 hours to get the results back, so that people in that drinking water plant are trying to treat the water that's flowing through that plant right now based on a sample and results they collected about a day ago or maybe 12 hours ago. What we need are real-time sensors for microsystem. That's what these 2 projects attempt to do. The first one with unmanned aerial devices, the second one with a microsystem detector. So this is a really important investment that could really change things as far as drinking water safety in Lake Erie. And I also want to note, as Bruce mentioned, that this is an important linkage between what's happening on this side of the river and the other side of the river. So we're trying to build collaborative networks here, not just within the agricultural college, but with the College of Public Health. with the Department of Electrical Engineering to get the best teams together to make important applications. Moving on from these first 5 projects, as I mentioned, the border regions contributed $2 million to this effort. With that, we identified 18 projects that were spread across Ohio universities. The border regions oversees Ohio universities, so obviously they wanted us to be expansive here. And we did partner with the University of Toledo to lead this effort. Very similar process, but instead of just engaging mostly faculty from Ohio State, we engaged faculty from across the state to determine what are the best projects to reap results and have benefits. So I'm not going to talk about all 18 of those today. I'm just going to talk quickly about 4 of those that I feel are pretty important. First of those is a farmer sampling network. This is work being led by Greg Labarge in the Office of Extension here within the college. And the idea here is to look at sub-watersheds, or very small watersheds, and try to determine what are the practices that are being implemented by these farmers with regards to field management, nutrient application, BMPs, and then combine that with downstream modeling. As Dr. Osmond said, this is a very hard thing to do, to try to link changes on the landscape with water quality, but we need to try to do this to understand which ones of these BMPs work. We're doing excellent work with edge of field monitoring. We have excellent watershed models at the whole scale of the Maumee watershed. We don't have much in the middle of that, so that's what Greg's trying to do here. We're also looking at a harmful algal bloom early warning system. This is work being led by the University of Toledo. It's going to take satellite data, environmental data such as temperature, water quality, and with these parameters try to develop models that will tell us, okay, a HAB event is likely to occur here in 1 or 2 days. So we'll have some forewarning of these events happening before they actually happen. Toxins in humans and fish. I already mentioned the fish part of this. So this is work that Dr. Ji-Young Lee and myself and Stu Ludson are involved in. The human work is being led by the University of Toledo. One interesting coincidence is during the water problem that happened in Toledo last summer, they were actually collecting blood samples in their hospitals there, and they happened to store those samples. So they're going back and mining those samples to see, are there microcystin concentrations in humans? What are those concentrations? Are they a threat? So that's something that's important to know. And the last one I want to talk about here is safe drinking water. Before I talked about monitoring the water in the lake before it got into the drinking water plant, this project looks at what's going on inside the plant. Right now at Toledo and many of the drinking water facilities within or along Lake Erie, they use activated carbon. One of the questions we're asking is activated carbon the best method to treat microcystin, to remove this toxin? What are the best ways to use activated carbon? And are there other options which are better? So another important project to protect drinking water as we move forward here. So those are some of the projects that are under the current umbrella field, the Faucet. What's really important right now is also to not only look at these new projects, but to integrate them with some of the current and ongoing work here at Ohio State and across the state of Ohio. Okay, we have a lot of great work going on here, and we need to build off that and integrate that with these new projects. I'm just going to mention a few of these key projects that are happening here. The Edge of Field Studies and P-Risk Index. This is work being led by Dr. Kevin King and USDA ARS here at Ohio State, just down the hall from me. Kevin has about 18 or 19 paired field stations, paired field sites in Ohio, just as Dr. Osmond recommended. And in these sites, he has one field which is conventionally managed, one field which is managed with a BMP. So he can look head to head to see how effective is this BMP at reducing the amount of phosphorus coming off that field. He's had many of these going for about 2 or 3 years. So as Dr. Osmond said, you want to have them going for 2 to 3 years in conventional management and then implement a BMP. So he's just at that point where he's leaping off to implement some BMPs. The other side of this is the Ohio Phosphorus Risk Index, or amending the Ohio Phosphorus Risk Index. This is work being led by Libby Dayton in natural resources, or the School of Environment and Natural Resources here at Ohio State. This is an important linkage here because what Kevin's doing is producing some great results from the field. What Libby's doing is taking that into the Ohio Phosphorus Risk Index and putting that into a tool that farmers can actually use to predict how these different practices will affect what's coming off their field and acknowledge what type of risk they're going to have on phosphorus runoff. So a great combination here. Fertilizer certification. This is important work and important collaboration. The Ohio Department of Ag is the issuing authority here. Ohio State Extension provides the required educational series. So since September, we've had about 6,500 individuals who have been trained in 110 sessions. Greg Labarge is leading a lot of this work. A lot of the funding has come from the college through funds related to Field the Faucet in the tune of about $1 million just to fund the personnel to make these events happen. So this is a way to get the information that's being produced from these studies that Kevin's leading and other studies into the hands of the fertilizer applicators that can actually use this information to reduce the amount of phosphorus coming off the landscape. Dr. Osmond mentioned the importance of the human dimension. So farmer decision-making and policy, vitally important. If we identify the best BMPs, if we know what's going to be the best BMP to reduce phosphorus, but farmers don't adopt it, we've really gotten nowhere. So it's vitally important to know how farmers make decisions and getting this into policy. Through an NSF project that I've been leading, I've been really lucky to work with some great social scientists here at Ohio State, Robin Wilson, Eric Toman, Eric Nisbet, Elena Irwin, Brian Rowe, and they've produced some really great results that have been influential for this project. I'm just going to flash one of these here. This is an example of different best management practices and the probability of adoption by farmers who are not currently using these practices. So what you can see here are 4 practices that farmers are very likely to adopt. The majority of farmers will adopt these practices, they say, within the next 2 years, and they're not currently using them. So delaying broadcasting when there's supposed to be a big storm that's coming down the way. Avoiding winter application of fertilizers. Placement of fertilizer 2 to 3 inches below the soil surface. And the last one here is following soil test trends. So it's important to know what types of BMPs farmers are likely to adopt, and then we can test them to see how effective they are. In contrast to that, it's important to know what types of BMPs farmers are less likely to adopt. And if we find out those are effective BMPs, find out what's the gap there. How can we change those BMPs? Do we need cost matches, as was suggested earlier? And lastly, I'd be remiss if I didn't mention climate change. Why is climate change important when we look at Northwest Ohio? As I mentioned, these are problems that are not going to be resolved within 1 year, within 3 years, within 7 years. It's going to be a decade or multi-decade time scale. Within that time scale, we know that the climate's going to change. So we need to be aware of this as we plan for BMPs or make greater management plans for the whole basin. What's going to be the effect of climate change? Are we going to have bigger rainfall events? It's especially important for harmful algal blooms. When you look at the literature worldwide, harmful algal blooms have been predicted to increase. When we look at Lake Erie, it's been predicted to increase for Lake Erie. The general idea here is that more spring rainfall is going to lead to more runoff and river discharge, and that's going to lead to more harmful algal bloom events. This has been hypothesized. Right now, a group that I'm leading along with Noel Aloysius, a talented postdoc here at OSU working on our NSF projects, we're one of the first groups to actually have some quantitative predictions related to Lake Erie where we've used global climate models. And we've actually found that there is going to be more spring rainfall. There's a large variation in what these global climate models predict. Almost all of them predict more spring rainfall, so we can be pretty confident in that. If we have more rainfall, we're going to have more runoff from the rivers in the spring. And yes, we will have more severe harmful algal bloom events. So we need to be very mindful of this. A bit of a silver lining here is I will note that these scenarios that we ran here were run with current land management on the ground. Okay? So if we keep doing business as usual, we will have more harmful algal blooms. But if we can implement some of the most effective BMPs that we identify, we can counteract climate change. Or perhaps we could even reduce harmful algal blooms from what we see in the future. So there's great potential for this, and some of the BMPs that we're testing with models, with edge of field results, do show great potential. I want to acknowledge a lot of our partners here. We couldn't do anything without our partners. Ohio academic institutions, I mentioned these before. I also want to take a chance here to acknowledge a lot of the great faculty I've had the chance to work with, graduate students and postdocs. Especially my own graduate students. I really cherish working with them every day. I wish I could see more of them now. So we do have a groundswell of support from academic institutions, from governmental institutions, from industry as well. I also want to point out that we have political support. So this is a picture of Stu Ludson and I. In between Stu and I, you may not recognize him here in a sweatshirt, but that's Senator Sherrod Brown. You often don't see a senator wearing a sweatshirt. I don't think I've ever outdressed a senator before. I didn't plan on doing it this day. We visited in Lake Erie last summer after the Toledo event, and Stone Lab set up a nice tour for us where we actually toured the harmful algal blooms and talked with Senator Brown about what was going on there. He was very supportive of our efforts. He did in fact surprise me though, because when I told him about our plans to launch a major initiative here at Ohio State to address this problem, he looked at me and he said, "You know, that's something I would expect Ohio State to do as a land-grant institution." So I thought about that a little bit, and I thought, well, maybe senators are pretty smart people, and it's hard to stay a step ahead of them. But he was really supportive of what we're doing here. So I'd like to end up by talking about a few next steps for Field to Faucet. One of the important tasks that lies ahead of me and others is managing our current set of projects for Field to Faucet and the Ohio Board of Regents. And I'm glad to have Ohio Sea Grant playing a leading role in this with me. So one thing I'd like to say to those of you who are funded with this money is do not expect to get any no-cost extensions. We want these to finish on time, and we want to have applied results, okay, that'll make a difference. Another goal we want to have is build important collaborative networks here. So have investigators from Ohio State, Toledo, Heidelberg, Bowling Green, having them work together to solve these problems. This will also allow us to form networks when new opportunities are released from NSF and other funding agencies, so we can quickly put teams together to play in these arenas to get these awards. Integrate research and extension at OSU with other organizations, accelerate applications, improvements. There's some things that different groups do better. Heidelberg NRCS, really good at installing, or Heidelberg USGS, really good at installing monitoring stations, collecting water quality, water flow data. Ohio State, great extension network, great research. NRCS, really good at providing cost shares to get things on the field. So let's identify what these different groups do really well and work together and move things forward as fast as we can. Important thing is to work to generate funding to support future Field to Faucet projects. I know Chris and Hillary are hard at work looking at commodity groups, industry groups, government groups, foundations to try to garner that next set of funding. And I want to point out that this funding is not meant to replace our traditional funding that we get from NSF, USDA, NEFA, and things like that. We need to keep doing that. But this funding is meant to augment that so we can have faster responses to these problems. We're also looking to develop a youth education component. I had limited time, so I haven't really mentioned that, but it's important to look to the next generation. We can't look to just farmers on the field right now, but look to the next generation coming up through high school, middle school, grade school, and we're going to work with 4-H to do this. And lastly, take this knowledge that we develop and apply to algal blooms and the situation across the globe as we learn from what's happening to other places across the globe. And I really hope that as we move through these next steps, as we follow on with these current projects, that we're able to improve water quality, protect public health, and sustain agricultural production. And if we do these three things very well, that will allow me that the next time I talk to Senator Brown, hopefully he will tell me that we've exceeded his expectations. So with that, I'm going to close, and if there's time, I'm happy to take some questions.